So good morning. It's my pleasure to welcome you in this session, which is network monitoring for the NREN community. My name is Baiba Kaskina and I work for TERENA. The session is organized by the LOBSTER project, and TERENA is a partner in the LOBSTER project, so it's my honor to chair this session. LOBSTER project is about building a passive network monitoring sensors infrastructure in Europe. And in this session, we would like to give an overview about the project, to talk about user cases, how actually this pilot infrastructure will be useful for users. And in the last talk, we will compare it with, not compare, but Nicholas Simar from Dante will tell us about similar activities in GN2 project, and we'll see how both projects can benefit from each other and collaborate. And the first talk of this session will be given by Evangelos Markatos. Evangelos is an associated professor in the University of Crete, and he is head of department in the FORCE, head of distributed computer system laboratory, sorry. And at the same time, Evangelos is a project manager of LOBSTER. He is deeply involved in all security aspects, so I hope he will tell you everything about the project, about the passive monitoring issues in the project, and what we will benefit from the project. So,
okay, thank you, Baiba, for the introduction. Let me try to find my slides. Yeah, these are the ones. Okay, welcome everybody to the first lecture of this session. My name is Evangelos Markatos, as Baiba said, and in the next 20 minutes I'm going to talk about network monitoring for performance and security, and focus on the LOBSTER project. Let me start by giving you a roadmap of the talk, what I'm going to talk about. I'm going to start my talk by giving you some motivation of the problem. Why are we doing this? To motivate the problem. In a few words, we are doing this because we believe that we need to understand the internet better. We need to have a better understanding of the internet in order to use it for better application performance, for early problem diagnosis, and for better security. Then, after the motivation, I'm going to focus on the work that we have been doing in 2 European-funded work on network monitoring, an R&D project called SCAMPI between 2001 and 2005, and the successor project of SCAMPI, which we call it LOBSTER, obviously, which is a pilot infrastructure, several SCAMPIs together, which is a project that's still running, is still running and runs from 2005 up to early 2007. So let me start by giving some motivation. Why do we need network traffic monitoring? I'm going to quote Kay Claffey from CAIDA, one of the most prominent researchers in the area of network monitoring, who recently said that, for the most part, we really have no idea what's on the network. She said that we can't measure topology in either direction at any layer. We can't get precise one-way delay. We can't get an hour of packets from the core of the network. We can't get accurate bandwidth capacity information. We cannot get anything from the core with real addresses in it. And again, for the most part, she said that we really have no idea what's on the network. Kay Claffey, prominent world researchers in the area of network monitoring. So, what is the problem? Let me now try to focus specifically on what is the problem we are trying to address with network monitoring. The problem is that we have poor network monitoring capabilities. And due to these poor network monitoring capabilities, we suffer malicious cyber attacks, such as viruses, worms, spywares, DDoS attacks, and so on. Those of you who were in the plenary this morning, you have heard about all these attacks and all those potential vulnerabilities and threats of our computing infrastructure. Our poor network monitoring capabilities do not allow us to answer a simple question like, which applications are running on our networks? It is a very simple question, but it is very difficult to answer. And sometimes we suffer what we call friendly fire on the internet, peculiar events on the internet, we call friendly fire, and these are unintentional attacks to major internet services. So, in effect, cyber attacks continue to plague our networks. I'm sure that several of you have heard about famous cyber attacks. In the summer of 2001, we had the Code Red worm, which infected 350,000 computers in less than 24 hours. It was the first worm to infect a massive, a large number of computers within a day, say, in 24 hours. Then, in January 2003, we had the Sapphire Slammer worm, which infected 75,000 computers in 30 minutes. This was the first worm that really practically demonstrated that it can infect a very large number of computers in less than an hour. And experiments now in the laboratories say that a similar number of computers can be infected in a few seconds or in a few minutes at most. So the technology exists out there, and it has been demonstrated to infect a very large number of computers in less than 30 minutes, and laboratory experiments suggest that they can be infected in a few seconds or in a few minutes. Cyber attacks and computer worms and computer viruses used to be a problem of PCs, of computers connected to the internet. As long as you don't have a computer connected to the internet, you don't need to worry about these problems. But this is not the case. Cyber attacks have started to infect our mobile devices as well, our palm tops and mobile phones as well. The first Pocket PC virus was called the DUTS virus, or Dust virus. It was a proof of concept, and in some way, it was a polite virus that depicted the following window. Once it infected your mobile phone, it said, "Dear user, am I allowed to spread?" If you press yes, it infected all your files. If you press no, it didn't do anything. So it was a proof of concept, and somehow it required user collaboration in order to spread. But the viruses that came after the DUTS were not as polite. After the DUTS, we had the Kabir virus, which infected the Symbian operating system. It didn't display such a window, asking for permission to spread. Then we had the mosquito virus, which infected, again, this Bluetooth devices and mobile phones, and so on. So let's try to understand now, why do cyber attacks continue to plague the internet? Because our defenses, in a couple of words, no, that's okay. In a couple of words, our defenses against the cyber attacks consist of 3 slow steps. The first step is detection, to detect that a cyber attack is going on. Although it may sound simple and trivial, it is not trivial to detect that you're under attack. Sometimes friendly fire looks like a cyber attack. Sometimes flash crowds look like a cyber attack. So the first step is to detect that there's a cyber attack going on. This is a semi-manual process, can be somehow automated, and takes several minutes. Then the second step, and the most difficult one, is fingerprinting the cyber attack. What does fingerprinting mean? Fingerprinting is to develop a rule, a signature, a machine-understandable signature about the cyber attack, a signature that identifies this and only this cyber attack and nothing else. Think, for example, a firewall rule, a rule that can be used by a firewall to block the cyber attack, or an intrusion detection system signature, a signature that can be used by intrusion detection systems to detect, or intrusion prevention systems to prevent this and only these cyber attacks. This is a very difficult step, and today it takes from a few to several hours, because it is a manual process. It is being done by humans in laboratories who capture the attack, who capture the worm, study the worm, and create a signature. But this process, because it is manual, takes several hours. And then the third step is deployment of signatures to firewalls and intrusion detection systems and patches, which takes from minutes to hours, but it can be automated. So now that we have the facts, let's try to understand, why do cyber attacks continue to plague the internet? Because on the one hand, I told you that detection, identification, and response to cyber attacks takes hours, because it is a semi-manual process. And on the other hand, I told you that worms spread on the internet within a minute, in less than half an hour. So usually, when we have the signature of the worm, when we have our defense set against the worm, it's usually too late. Probably most, if not all, computers will have already been infected. And the key challenge that we have to face today is, can we respond to cyber attacks faster before they spread to all the computers to reduce the damage? We believe yes, but we need better network monitoring. Now let me turn your attention to another problem that is trying to motivate why do we need better understanding of the internet. Here I have a screen dump of some statistics from the University of Wisconsin for an entire week. So here we display the traffic of the internet-connected link of the University of Wisconsin and the categorization of this traffic to different applications. So if you can see the colors here, this purple corresponds to the Kazaa traffic. Look, the purple here is Kazaa. If you can see the yellow one, the yellow is Nutella. If you can see the brown one, you can barely see it here, is eDonkey. And generally, these are identified peer-to-peer systems. Then we have the red one, which is HTTP, usually web traffic. Then we have the green one, which is FTP traffic. And then there are some other traffic categories as well, which are very difficult to see. NNTP, which is the news server, the real server, real audio, real video. SMTP, which is the email, ICMP, the ICMP protocol, and so on. But the most important thing to read from this figure is this big white space here. That big white space corresponds to other applications. And that big white space corresponds to 69% of the traffic, 69.4%, which means that we cannot accurately categorize 69% of the traffic. 69% of the traffic is unaccounted for. Maybe it belongs to peer-to-peer applications that use dynamic ports. Maybe it belongs to media applications that use dynamic ports. Maybe it belongs to applications that we don't know, have not heard of yet. But the bottom line is that using our network monitoring tools, we don't know. And let me turn your attention to a third problem, which we call friendly fire on the internet. What is friendly fire on the internet? Here, I have a screen dump created by Qaeda, where they were monitoring their DNS servers. And they were printing the load on root DNS servers. And here is a screen dump of the loads for a period of 100 minutes. And the load is very low, close to 0%. And suddenly here, at minute number 60, the load suddenly increases. Increases, say, more than 10 times the ordinary load. And then decreases again. And then suddenly increases for a second time. So we see this sudden increases in the load that, to a naive eye, look like an attack, something like a DOS attack, something like a DDoS attack. But no, the problem was traced to Windows 2000 and Windows XP computer, which, for no apparent reason, at the same time, they started updating root DNS servers. Several hundreds, thousands of Windows 2000 and Windows XP computers at the same time updated root DNS servers and created significant load to DNS. This was not a malicious attack, but something in their software prompted all those computers at about the same time to start updating the DNS server. So let me try to summarize the problem. And the problem is that our understanding of the internet needs to be improved in order to understand cyber attacks, in order to understand traffic categorization, in order to understand and avoid friendly fire. And the gap between what we measure and what we need to measure and understand is large and is getting larger. And let me show a pictorial visualization of the gap now. Again, we see the traffic from the University of Wisconsin, but not for a period of 2 weeks, but for a period of 2 years, from 2004 up to from 2002 up to mid-2004. And again, we see the same traffic categorization, and I would like you to focus on this gap here, which is the unaccounted for traffic. Back in 2002, the unaccounted for traffic was there, but it was, say, a small percentage. And that percentage, with the years, started to increase, and today it has reached, as I saw in the previous figure, up to 69%. The actual percentage may vary, but the trend is there. It started from small, and got big. The gap continues to widen with time. How are we going to solve the problem, close the gap, and understand the internet better? We believe that we need better internet traffic monitoring. Better means faster, which means detect worms before they infect the entire planet. They have the capacity to infect the entire planet in half an hour. Laboratories experiments say in a few minutes. So we need to respond faster to them. And more accurate means that we need to close the gap between what we know and what is really going on out there. So network monitoring is a solution. Network monitoring, it is a good idea. We were not the first ones to think that network monitoring is an important problem and is the solution to understanding the internet better. But back in 2001, there was a committee formed in the United States, the Committee on Research Horizons in Networking. Smart people were in the committee. David Clark from MIT, this is the father of the end-to-end argument. David Patterson from Berkeley, this is the father of the RISC computers and the RAID disk arrays. And all those people, the smart people, gathered together and they identified 3 challenges for research in the area of networking. 3 challenges for research. And one of those 3 challenges was to develop and deploy the technology to make it possible to record a day in the life of the internet. That is, monitor the internet for an entire day. Monitor the entire internet for the period of a day. This is one of the 3 most important challenges in networking that have to be met in the near future. So what I would like you to get from this slide is that smart people believe that network monitoring is a major challenge that has to be met. And for the last few years, we have been trying to do that, to meet this challenge, to make contributions toward meeting this challenge within the SCAMPI and LOBSTER project. And let me start with the SCAMPI project and give you a profile of the project. SCAMPI is an IST R&D project. It was funded by the European Commission, started in April 2002, and completed successfully in previous March, 31st of March 2005. The goals of SCAMPI was to develop a passive monitoring platform that will be able to capture all network traffic and examine it. The technology to be used was to develop a 10 gigabit per second FPGA-based card, design and develop a monitoring application programming interface called MAPI, a new programming interface especially for monitoring applications, and develop efficient monitoring applications. Some of the achievements of SCAMPI are in the area of security. We designed and developed high-speed intrusion detection systems. You can think of intrusion detection systems as devices that are tried to detect intruders in your network. For example, they are able to answer questions like, find all packets that are being sent to my network and contain the code red worm, or find all computers in my network that are infected with backdoors. We have also done some development in DDoS attack detection mechanisms, and also some performance analysis by using monitoring in order to understand the performance of applications better. We are able to answer questions like, what percentage of my traffic goes to Kazaa or other peer-to-peer systems, or what is my network latency to CNN.com. Other achievements of SCAMPI, we believe, is portability. MAPI, the monitoring application programming interface, has been ported to several different platforms, like commodity network interfaces, ordinary interfaces that you can buy for 20 or 30 euros. And these DAG packet capture cards, these are special purpose interfaces that can work at very high speeds. The SCAMPI card that I told you was developed in the project, and parse implementations also exist for Intel IXP network processors, and some are still ongoing. So the key understanding here from this slide is to understand that monitoring applications with MAPI are written in a high-level programming languages, and there exist different implementations of MAPI from several different hardware platforms. So the monitoring application can run on top of commodity interfaces, on top of DAG cards, on top of network processors, on top of whatever platform there exists out there. Some other achievements, we believe that MAPI provides high-level abstractions, which are ease of use. It is more expressive. Users can better communicate their monitoring needs to the system, and in turn, it's faster. Because once the system knows the monitoring needs of user, it can better map them into the underlying hardware. And the end result is improved network monitoring capability. Now, let me turn your attention to the final project, the LOBSTER infrastructure. Within Scampi, we developed a single passive network traffic monitoring platform that is able to monitoring a single line, a single interface, one interface only at a time. Within LOBSTER, we are thinking of interconnecting several of those monitors, interconnecting several Scampis together, and create a network of passive internet traffic monitors. We believe that such a network will be based on cooperation, which means individual monitors will exchange information and observation, and will be able to correlate results. LOBSTER is a specific support action, which is funded by the European Commission. It's a 27-month project and started last October, and it will end at the end of 2006, December 31st, 2006. Although LOBSTER seems a straightforward extension of Scampi, it is not. There are several challenging issues that have to be met within LOBSTER. And the first challenging issue that we have identified is trust. Cooperating sensors may not trust each other. They may want to cooperate and exchange some kind of information, but they don't completely trust each other. They don't completely to send all the data and to share all the data with the other sensors. Within this data, there may be private and confidential information. And monitoring sensors may need to protect this private and confidential information. And within LOBSTER, we provide the infrastructure to protect private and confidential information through multi-level anonymization techniques. So, for example, internal users of an infrastructure of, say, an organization may have unlimited access to the organization's data. But this data may be available to the outside world only in an anonymized fashion. Within LOBSTER, we provide a multi-level anonymization approach that can be tuned by system administrators, and provide the actual level of anonymization to the appropriate users. Again, the same example. Internal users may have access to probably most of the data. Outside users may have access maybe to anonymized data or only to a summary of the data or aggregates of the data or statistics or something like that. Another challenging issue is that we need a common programming environment. Within Scampi, we said that we need a programming environment to program a single monitoring platform. Now that we have a network of monitoring platforms, several monitoring platforms out there, we need a new programming environment, a new programming interface, which we call DMAPI, Distributed Monitoring Application Programming Interface. And as the name suggests, it will be an extension of MAPI. And the third challenging issue is resilience to attackers. We hear today in the plenary talk that attackers penetrate most of computers. So what if intruders penetrate the LOBSTER monitors? What if intruders penetrate the LOBSTER computers? Will they be able to have access to clear text, private and confidential data? We believe that the answer is no. Because within LOBSTER, we'll provide the users with hardware anonymization. Anonymization done directly on the card before the data are transferred to the main memory of the computer. Of course, this level of anonymization will be tuned by system administrators. So, okay, if you have a question, you can talk about it. You can give the question later. So the level of anonymization can be tuned by system administrators, and only anonymized data may hit the main memory of the computer, depending on the actual policy that has been implemented. So what's some potential LOBSTER applications? One obvious LOBSTER application from the motivation that I gave previously is accurate traffic monitoring. Remember that the gap here, that white space here, means that there is a significant percentage of the traffic we cannot categorize. And accurate traffic monitoring means that we are able to answer questions like how much of your bandwidth is going to file sharing applications, such as Nutella, which applications generate most traffic, and so on. other potential LOBSTER applications are early warning systems for the automatic detection of cyber attacks, like automatic detection of new worms. Such early warning systems may be able to detect worms within minutes. They'll be based on a collaboration between individual monitors, and that collaboration will give greater confidence to the acquired data and may be able to detect worms much faster than a single sensor can. They will be parts and they'll contribute to early warning systems that will alert administrators and users about potential attacks, and this will lead to a timely response to worms, generating attack signatures. Some other potential applications: grid computing, grid performance debugging. Grid-enabled applications are highly dependent on network characteristics. They may access data that are remotely. They may access remote resources like sensors, instruments, and so on. And they may use remote computing power. So they are highly distributed, and it's difficult to find out if those applications do not perform as expected, if they're not as fast as expected. It's difficult to find out what is the problem with the application, what is the bottleneck in their performance. Is it the local area network, the wide area network, the remote local area network, or what? Is it the local computer that's overloaded, the remote server, a middleware server, or what? So we believe that LOBSTER and similar infrastructures will help towards better grid performance debugging. What are the users that can benefit from LOBSTER? We believe they are NRENs and ISPs, who will have better internet traffic monitoring of their networks and better understanding of the interactions with other NRNs and ISPs. Security analysts and researchers, they'll have access to anonymized data and access to anonymized testbed. They'll study trends and validate research results. And network and security administrators, they'll have access to a traffic monitoring infrastructures, access to early warning systems, and access to software and tools. Now let me summarize my talk by repeating again the motivation. And the motivations say that our understanding of the internet needs to be improved. This is a very important problem, understanding the internet better through network traffic monitoring. And there was the committee in the Research Horizons in Networking that said that this is one of the 3 most important research challenges in the area of computer networks. And there are also prominent researchers there that say this is a very hard problem. Because as Casey from CAIDA said in 2004, for the most part, we really have no idea what's on the network. We believe that Scampi and LOBSTER are a step towards providing better network monitoring through high-end passive monitoring systems and distributed infrastructure of monitoring system, this is LOBSTER, trusted cooperation in an untrusted world, a common programming platform, which is DMAPI, and infrastructure resilience against attacks. I would like to thank you for your attention, and if there are any questions, I'll be happy to take them.
Well, thank you, Evangelos. The questions, please. Yes.
Wait a moment, okay?
No, microphone. Is this my glass?
Yes.
You are right. We suspect that we don't know for sure that most of this unknown traffic comes from applications that use dynamic ports. One idea that supports this suspicion is that Kazaa here, back in 2002, this is the purple one, had a noticeable percentage of the traffic. You can see the purple up there. But in 2004, it has completely disappeared. So this probably means that Kazaa is still there, but it uses dynamic ports. It uses a mechanism that can evade the traditional network monitoring tools. So yes, we need better protocol analysis in order, again, to find Kazaa and to put it in that transparency. Yeah?
You're monitoring enough traffic there, and there's not a high packets per second rate is very
Yes, let me go to the Scampi. Okay. One of the major challenges of Scampi is to develop a 10 gigabit per second FPGA card that can capture all network traffic and examine it. So you are sitting in front of Jiri Novotny, who did most of the research in that area, and they have developed cards that they can get the traffic and in hardware, not in software, examine the network packets. Examine means they can examine their header, or they can search for string in their payloads. So if we know that Kazaa contains the string, say, Kazaa, we search in hardware for the packets that contain this string only, and then we send these packets to the higher levels for higher level protocol analysis. So in hardware, we are able to reduce the number of packets, the traffic that we send to higher level analysis, to a larger percentage.
Okay, so with slide start analysis, at some stage, you have figures there for 2 years.
Yeah.
So is there any, is it stored some sort of database of binary files, or are you using a database to store this information?
No, we don't store, it's not our traffic, we don't store this information. This information is available on the internet. It is stored at the University of Wisconsin, and I don't think they store the entire packets for 2 years. I think they store only summaries of packets, say per day or per week or something like that. They only store the statistics, not the packets per se. Yes?
Probably there is no microphone, so you have to speak loud.
I'll speak on. The networks here are paid for by the universities and the NRENs, right? And more than half the traffic on them is unaccounted for, right?
Yep.
Is it perhaps possible to conclude that they don't really care what is going on the network that they pay for? And half of the money that they
I don't think so, because this is statistics gathered from the University of Wisconsin, which are very advanced in network monitoring, and they publish papers, they participate in conference, and they really do care about network monitoring. So my interpretation is not that they don't care, but the technology they used to analyze the packets, the traditional technology they used, just wasn't able to close the gap.
What is this unaccounted traffic doing? Is it part of the functional requirement of their network? You've indicated certain things there like HTTP and SMTP, which are functional requirements. People need to browse, need to send mail. Do they need to do these other things? If you do it for
We don't know. If we cannot account for this traffic, we don't know what this traffic is. Could be HTTP, could be web traffic not going through port 80. Could be legitimate traffic. Could be peer-to-peer traffic. Could be peer-to-peer legitimate traffic that uses dynamic port. The bottom line is that we don't know.
If you stopped it, you might find out.
Right, there was one question up there.
That's a good one. That's a good one. Yeah.
We-
Continuing on this one, monitoring the network is not the only way of finding out what's on the network, because there'll be a lot of traffic on there you could find from where it was coming from.
Yep.
Or you could find the server that it was being served out of. There would be a lot of traffic on that network you could identify other ways. So the 69% you can't monitor on the network does not mean 69% of unknown traffic. You need to be careful here, because there will be a lot of traffic on there. You could be running, for example, SAT as a service, which uses dynamic ports.
Yep.
You know from the statistics on the SAT server the type of amount of traffic you've got of SAT. So you could then add that to this. So this is only looking at the network.
You are right. This is only network traffic monitoring without any information from the end host. One approach is to augment the end host, the sending and the receiving end, to provide such information. But this is a different issue. It requires resources. It's a question of deployment. It's a different issue. But this graph can be helped by host information.
All right, the last question. No, it was Angel Cormac. No? Okay, then your last question.
I was with data inspection and with protection, you have a lot of protocol analysis. For example, a lot of people use port 80 for all sorts of traffic, so that they can,
yes, I believe they can help, and especially if they are helped by specialized hardware like that has been developed by Masharek University. There also exist in the market out there cards that do that kind of protocol analysis, first level protocol analysis by NDAs. There'll be a talk by NDAs in the session after this one. You can buy these cards, and they do some kind of filtering and pre-processing directly in the hardware so that the information that you get up there and you need to process, it's much less, and it can be processed by a general purpose processor.
All right, thanks, Evangelos, a lot.
Thanks.
We can sing again. It was interesting.
Oh,
and,
the microphone.
Now let's move to the second talk of this session. The talk will be given by Rutger Kullen from TNO, which is also a partner in the LOBSTER project. And Rutger will talk more about the user cases, how actually we will be able to use the LOBSTER infrastructure, what will be benefits for users and particularly for the NREN community. I hope he will present some user cases and you will express your opinion. Do you think it's useful or not? So let's start.
Okay, thank you, Baiba. Good morning, everyone. In this presentation, I will go into in more depth into what can we do with the LOBSTER infrastructure. So you can see this as a follow-up of the presentation by Evangelos. What I want to do is first look at LOBSTER from a few different angles, go into the actors that are involved in such an infrastructure, then explain the approach into use cases and give you 2 example use cases. I think one of the most important parts of this session can also be that you can give your input. And you can ask questions during the presentation, that's okay. But we also have a part of the presentation which is also for you to give input on what you see here on use cases. So we can use that input to tune the requirements in the LOBSTER project. And finally, I'll end with an overview of the current status. So if we look at LOBSTER, we use the term LOBSTER and then we often mean a couple of different things. First of all, the project viewpoint, as Evangelos addressed. The LOBSTER is a project under the EU Framework Package 6. But okay, that's the project way of looking at it. Furthermore, in the project, we're building a pilot infrastructure with the consortium partners, some of which are the NRENs themselves. So if we talk about LOBSTER, we also mean we're looking at an infrastructure. But finally, also, we see LOBSTER as a community of network operators, NRNs, ISPs, that together operate these monitoring sensors that can actually monitor the data on the network. So that's just to make clear, if I talk about LOBSTER, it's one of these 3 I will be probably talking about. So if you look at the actors, first of all, the LOBSTER community. What we're aiming at in the project is to have primarily the NRENs to have these monitoring sensors in their networks and use these for various applications. And I'll give some examples in this presentation. And secondarily, we look also at commercial ISPs or other ISPs that are interested in sharing network monitoring information. If you look at other potential users, well, think of your customers, including the researchers and the analyzers. Maybe also policymakers, government, and so forth could be potential users, of course, depending on what they want to do with the data. So the approach taken for the use cases. First of all, it's good to say what are use cases. Well, the use cases are applications of the LOBSTER infrastructures. Use cases are not the business case for buying monitoring hardware and joining a community such as LOBSTER. So what we want to do here is to demonstrate potential benefits of LOBSTER and also to derive some requirements. So what should a LOBSTER infrastructure look like, or what should a community do? And the most important thing, if you look at the use case, is that you include the characteristics of what you're looking at, in this case, the LOBSTER project. What you see here at the bottom is that the most important thing is that LOBSTER addresses things that are beneficial for its users, obviously. Also, one of the important things in LOBSTER is privacy. There are always business and organizational confidentiality requirements. There is privacy legislation, and LOBSTER includes, as Evangelos discussed, some anonymization features. Secondly, LOBSTER focuses at cross-domain problems, at multiple domains. So what we are looking at are use cases that address the cooperation between NRENs and other LOBSTER users, and that focus at inter-domain problems. Thirdly, advanced monitoring. What we're looking at here is state-of-the-art monitoring hardware. We're looking at monitoring hardware that is advanced, and that's, for example, are the cards that come from the Scampi project or the Endace cards. There will be a session on that at 2 o'clock this afternoon, which focuses more on the advanced network monitoring technology, which will also be in this room. Finally, the high speed, we're looking at advanced hardware, and should be useful, of course, for the high-speed networks that we're using. So these are the characteristics that we would like to see met in the use cases. Well, this is an overview of the approach that was used, the template. Okay, let's go into first example. Well, the title of this example, Collaborative Worm Detection. The idea is here, we have a couple of NRENs that have monitoring sensors deployed. So the monitoring hardware is deployed, and it's denoted here with these orange boxes with MP, which is measurement point, or could be monitoring sensor. The idea is that computer security emergency response team is somehow capable of detecting a worm and making a signature of a worm. And this should, of course, be done as fast as possible. The idea what we can do in LOBSTER now is spread such a signature in the system so that we're capable of detecting worms throughout, in this case, the LOBSTER community. So what happens at such a LOBSTER measurement point? For example, the sources of worms could be detected. So we make sure that the hardware detects the source IPs of the various worms. We're capable of doing that because the community spread a signature of this worm. So third step could be that an incident response team takes actions based on these worm source addresses. First action could be to block source addresses, for example, on access routers for the customers, or maybe route customers to special websites that warn them they are infected by a worm. These are examples. And of course, if you're looking at speeding up worm detection, it would be better if somehow this could be automated or semi-automated. Because if we want to do this worm detection within minutes, then of course you need a lot of automation instead of the non-automation. A second example of an action could be to email lists of infected computers to customers, to universities. And a related use case would be to have the worm sources collected, anonymized in some sort, for example, provide counts of the worms. Combine that as a community so you can get the overall statistics of worm spread in Europe. Second use case, which goes into more of the advanced services monitoring, performance and quality monitoring. Well, for example, look at inter and intra-domain call setup and data streams in voice over IP or video conferencing. Technology that is used more and more also in the NREN community and also in the general network community. So what we want to do is use the measurement points to look at the call setup and the streams, to look at firstly intra-domain traffic, which we can measure it because it's in our own domain, and also look at the streams that are going in and going out. And because often these protocols use dynamic ports for the streams, and the streams are in UDP, and the signaling is done in TCP, that's one of the motivations that we need the advanced monitoring hardware to do these kinds of applications. What LOBSTER also does, well, at least LOBSTER can provide also that NRENs that you cooperate with also measure data for you and give you the data. I call it here the partial raw data because probably you don't want to have other partners to have direct access to measurement points and to be able to monitor everything. But it could be possible to give anonymized streams or filtered data streams, which help, in this case, the NREN number 2, to get an overview of what is happening, what's going on in the various advanced services we're talking about now. Well, if you combine these from various organizations in the LOBSTER community, for example, you could have an overview like this, which says, okay, from this NREN to that NREN, we have so many calls a day, so much data going on, and also we're able to measure the average mean opinion square and give an identifier of what is the quality of conversations or video conferencing that we're talking about. So this is a second example of what you could use the LOBSTER infrastructure for, and what you could do as you cooperate in the community with these kinds of hardware nodes. So this is to give you an overview. So we have different actors and we have different cases. And you see the various actors will have different will make different use of what we've seen in the cases. Well, more use cases, some were addressed already in the first presentation as well. Security is a very important application for LOBSTER because obviously security requires, first of all, some form of advanced monitoring and also some form of collaboration. Security is always a thing that it won't be harmful to cooperate, especially if you look at more commercial operators. There will be some. There will not always be an incentive to cooperate, but for security there usually is. So other applications could be spyware detection, denial of service attack detection, or even better, detect control traffic. So you're even one step ahead before denial of service attack starts. You're able to detect, okay, where are the master and slaves, for example, in the distributed denial of service scenario. What you could also do is detect traffic to backdoors and so forth. So as a computer security incident response team, you could use this information to warn your customers and so forth. So these are all similar to the worm detection scenario. Performance measurement, a very important application for the LOBSTER monitoring. For example, measure things on delay-sensitive grid computing or online games. Well, in this case, then educational games, but maybe games in general. Or give an overview of what is happening on your network again, so network traffic characterization. Can we measure peer-to-peer applications, or services with dynamic ports, and so forth? So these are some use cases similar to the two examples I just presented. Right, well, I'll be happy at this point in the presentation to already take questions you have or remarks you want to make. For example, reactions on the use cases, or maybe you see certain requirements evolving from these cases.
Yes. I'll ask a question to nobody else. The use cases are okay, but there's a couple of conditions that I can see we're going to have problems with. First of all, what do we do when traffic we're trying to monitor is coming through as an encrypted data stream, and the only thing we can see is the header. And the second part of that, which goes with that, is we're seeing the development of dynamic port hopping, i.e. dynamic ports which actually change as the protocol is running. Because again, they're trying to hide what's going on. So we're seeing this beginning to occur, and obviously it starts off in the military and it moves into the non-military and probably the research. So we're seeing traffic that's fully encrypted except for the header, and the ports themselves change while the stream's going on. In other words, they keep dynamically changing the port because they want to hide what's going on. Are these things going to make this a bit of a problem from a point of view of monitoring the traffic?
Okay, let's give a reaction then on encryption part first. It will be very hard, or maybe even impossible to, well, you can monitor the encrypted traffic, but to make any useful information out of it will be very difficult. It's only possible if you have access to the keys and the crypto algorithms, which is in this scenario not very likely. So the only thing you could do is, if you can see the headers, depending on how many headers on what layers you can see, you could have an overview. Okay, this part is used, for example, for IPsec traffic, but you're not able to see anything what's happening inside the encrypted traffic. So that's certainly a problem. If the scenario would be that encrypted traffic increases very rapidly, then that would be for these kind of.
If we followed the plenary session this morning, we'll all be using encrypted traffic, won't we? After the speech you gave us.
Maybe. I think there are various opinions on that. I think maybe a reaction on your second question was, okay, what can we do with applications that change ports during sessions? As long as you know the algorithm that's being used for that, and you're able, or maybe if you're able to, if you know what strings to look for within the content of the package, the LOBSTER monitoring hardware is capable of dealing with these kinds of things, but you would have to make changes into the, well, you would have to make special, how do you say it, algorithms to detect these kinds of things. Oh. Sure.
So Andrew Cormack, I think one comment on the encrypted, a big source of encrypted traffic is the grids. Because grid FTP is an encrypted peer-to-peer protocol using dynamic ports. And that is going to be a large chunk of your white unknown. I wonder whether maybe a question for the hardware, whether the hardware can actually look at byte characteristics and distribution and say, this is completely random, therefore I presume it's encrypted. You might be able to do that. The other comment on what you said, my background is in CERNs. I like the idea of the worm detection. I actually like it a lot more than what I thought you meant in the title, which was actually going to be trying to do the characterization distributed.
Mm-hmm.
I like the idea of pushing the signatures out. I would be very wary about automated response, because bear in mind the slammer worms spring using UDP, so I can forge the source address with no problem at all, and you're going to be taking automated response against. I pick wherever I want my packets to come from, and you will cut those off. And the use case that really put me off dynamic response was a large educational content provider who had been sold by their network provider with a dynamic firewall was what they wanted. The dynamic firewall saw a huge attack coming from a single IP address, blocked it. It turned out to be AOL's outbound proxy. And they suddenly lost most of their customer base. So be very careful with automated response.
Yeah, I completely agree with this point. It can be an attack or a means to attack, but it's a difficulty, right? Because you want to be able to detect these worms within minutes or maybe hours, but fast. You also want to be able to respond fast. So you need some sort of maybe human intervention there, but it's a very, very difficult problem. So how to make an automatic response system which is tolerant to attacks.
Very hard. I know some research into this, but they use a honeypot for getting signatures, and they train the whitelist for
Interesting. Ah.
Or if you wanted to do automated response, could you use Lobster to feed into traffic shaping rather than simply blocking? Just say slow this down. So you're not actually killing customers, you're just degrading gently.
Yeah, I like these kind of ideas because in Lobster we mainly now focus on the monitoring part, right? But if you really want to do something useful with it, you need to look at, okay, once I have detected something, what am I going to do with it? And then you need to discuss with these kinds of ideas. And if, yeah.
Mike Norris, HANA. The different scenarios and use cases I think are very interesting, but they are different, and people might ask why they should use this in the case of, say, statistics or performance monitoring when something like the right TTM are already there and they've invested in these for measuring performance indicators and traffic performance over the network between many points, not just within Europe.
Well, as I already said, this is not about the business case for going into this, so that's maybe also part of your question. Personally, I think there is so much to be gained on network monitoring that you will want to have both the active and, in this case, the passive monitoring. So I think these can coexist, and it would really depend on what use case you're looking at, what would suit your needs best, I would say.
Security monitoring, as Kai here said, you have state analysis, you see where the connections are originating, you know how your firewall is operating. If you're monitoring traffic coming into the university, you can see who's starting the connection. So that should give you a good idea of what's passing the firewall. So that's another area of security monitoring.
Mm-hmm.
See connections originating from outside into inside. You get a better overview of how the firewall is operating.
I think if I understand your question correctly, but let me know if I'm wrong. I think in Lobster we're now looking at mainly at the operator level, at the NRENs to monitor at that level. It would even be much more useful, but even also more complex to realize if you would also be able to have monitoring sensors at customer sites, for example, at universities. And then you also, for example, I think you say, okay, then you can also see what's happening, what is your firewall doing, for example. The thing is, the NREN community is, well, it's, I'm not sure, but it's like a couple of tens of organizations, and all the customers will make it hundreds of organizations. So it would be difficult to organize, but interesting. Oh.
Thousands.
Thousands.
We have 1,000 on one NREN.
Okay.
Yes.
Thanks.
I wanted to ask if you have run any analysis and comparison with NetFlow data, data taken from the routers, and if you found any, let us say, connection between the analysis of the packets with the LOBSTER project and the NetFlow data analysis. Did you find any relation?
What we're looking into is, as a research project, we're doing that together with the Vrije Universiteit from Amsterdam, Netherlands, is to be able to look at strange flows in the network. For example, if you see a peak in traffic going to a certain port, which could indicate that there is a worm, and then combine that with LOBSTER, say, deep packet inspection techniques, and to see how we can combine it. But that's still in the research phase. What we now think is that NetFlow alone is not enough, for example, to detect these worm signatures. So that's why we think it's very useful to have also deep packet inspection, so to have the advanced network monitoring from the Scampi and the LOBSTER projects. Yeah.
Yes.
Your professor, in a couple of slides that you intend also to detect backdoors. In my opinion, backdoors are something really hard to detect. Like, describe some more on like this kind of
I think this would typically be a discussion to take offline of this session, but the general idea I can say is, okay, in this backdoor traffic there should be some of identifier, for example, for a certain backdoor, if there's a string or whatever, a characteristic in these kind of streams you can detect, then you can do it. If there's some sort of randomness about it, then it will, I agree, then it will be very hard. We can talk about it later.
All right.
Yeah, let me conclude with a final slide. Maybe a quick summary and, well, a quick look into current status. We're working on the implementation of the pilot infrastructure with the LOBSTER consortium. We have, you could say, an initial community with 3 of the consortium members are NRENs. It's Fortinet, Uninet, and SESnet. So that will be our first LOBSTER community we'll be working with. We're also looking at the relation with Geon2, especially JRA1, and the next speaker will go into that. And I think important is that you're invited to join the efforts and to look if you also would like to become part of this LOBSTER community and develop these use cases for monitoring. Thank you.
Thank you. Thanks, Rutger, for interesting presentation, and thanks for all the comments. I tried to take some notes, so we will try to at least summarize and maybe use them somehow. And as Rutger already mentioned, there is a last talk of this session, and it will be given by Nicolas Simar from Dante. Nicolas is working in the network engineering and planning team for Dante, and he is involved in GN2 project, not only in GN2, I know also in EEG and probably in some other activities. But right now, Nicolas will talk about GN2 JRA activities, and particularly about things which are relevant to LOBSTER project, also mentioning how these 2 projects could benefit one from another and cooperate. So, Nicolas, I'll get the slides.
closer. Okay. I hope it's better. Yeah. The second tool is the BWSTL, which is a wrapper around iPerf to do some TCP throughput test when you've got performance problem. You want to check, is it the network? And the third one is the round-robin database type of information. Most of the existing networks have their information within the round-robin database, and we want to help them to publish those information more easily. At a later stage in the project, we would like to introduce net flow information as well as packet capture type of information, because we think that can provide a very good added value to the overall community of the overall Gen2 community. And finally, we also intend to build visualization tool to demonstrate the usefulness of getting data from different domains for troubleshooting and so on. So here we will follow what SA3, so the end-to-end troubleshooting group, would need. And if you want to know a bit more about that, there will be a presentation about GRA1 itself tomorrow. So that's a bit how GRA1 will look like. So you've got the networks with different measurement tools within them. GRA1 will provide a framework to allow the exchange of monitoring information between the different networks. And on top of it, anybody could build clients and interact with the framework deployed within the different networks to retrieve monitoring information. And basically, the services GRA1 will provide are start, stop a test, or stop retrieving some specific data, archive the data, discover which are the network measurement capability, what are the measurement points which are located in the network. Have you got a one-way delay type of measurement points? So this service would tell you, yes, there are some in that and that place within our network. We will also be using the AA service worked on by the Gen2 GRA5. And then we'll also introduce transformation service in case you need to have a slightly different format for your data and so on. So what are the similarities and the difference between Gen2 GRA1 and LOBSTER? So for what I've understood, but I'm not involved in the LOBSTER project, so you may disagree with some of the points, of course. There is a need to have a framework to communicate information between different domains. This implies that we would have some common requirement to have an AA infrastructure, potentially do some resource management, and have standard interface to exchange the information. And then both projects will be using user traffic as primary source of information. So which are the implications in terms of privacy and so on. This is something, as GRA1, we don't know, and we would be very much interested to hear from you about. And then if we cannot exchange those information, how can we anonymize them? That's also another area which is interesting for us to know about. So the differences. LOBSTER concentrates mostly on passive monitoring, whilst GRA1 used primarily active monitoring, one-way delay, TCP throughput, and so on. But in the long run, we don't intend to just work on active monitoring. We are also very much interested on passive monitoring, net flow, or packet capture type of tools. So there's another point that Sven mentioned to me, that LOBSTER need to run multiple applications on a single monitoring station. And right now, GRA1 doesn't have this issue right now. But in the future, we will need to integrate many different tools into a single PC. But so far, we can avoid this problem. And GRA1 is looking, it's possibly not a difference, to promote the packet capture utilization within the NOC and show what can be the added value for them for such tool when they are confronted to performance problem. Again, we are not intending to have packet capture deploy everywhere and so on, but just to show with a packet capture tool, this is what you could do. Is it of interest for you? And if yes, in which direction would we need to go? That's the main point we want to, that Jerome want to pass to the NOC. So how can the two projects work together? There are different ways of seeing it, but for GRA1 point of view, the LOBSTER product and project could be seen as a measurement point from which we are retrieving information to export it to the outside world. There are lots of very good work which has been done there to make independent the capture element. So it can be an NDACE card, it can be a Scampi card. You have the LOBSTER project have already abstracted that. So that's very good for us because so we don't have to work on those different parts. So if we could kind of interface ourselves with the LOBSTER infrastructure, we would be able to retrieve packet capture type of information and export it through our interface, through a standard interface that GRA1 is building. And that raises a question, what would be this interface between the LOBSTER project and the GRA1, and where would it be? As additional points, GRA1 would be very much interested to hear about the privacy issue, as I mentioned earlier on. Most importantly, in relationship with the multi-domain exchange of such information, which are the anonymization technique that could be used? Are there some which are not easily sorry, I won't manage to have that one. Are there some anonymization technique which cannot be easily reverse engineered, where you could not inject traffic through the different network and find and then reverse engineer to find out, oh, that's how they are anonymizing the data, so I can go back to all the other, I can find out all the other information. And then are there some recommendation regarding the storage of those data? You've got quite a lot of expertise in that area, and we would be very much interested to hear about them. And there is also the COMO project from Intel Research Cambridge, with who we are, as Giant, are working closely with, and we may be deploying some of their probes within our network. And as there are lots of projects working on passive packet capture type of monitoring, it would be very good for us if we could access the information from those different projects in a single way, in such a way that we could support different activities within our own networks. The next Gen 2 activity is the GRA2 on security. Okay. Basically, GRA2, amongst its work packages, is working on a tool set to provide new security information across different domains. So they started from the assumption that they don't want to exchange raw monitoring data between domains. They just want to exchange analyze post-process type of information between different domains. So they're building a tool set which covered capture of information, storage of the information, processing of this information. And if there is something happening, then they are sending an alert to the other domains. And they will first be starting with net flow type of data. And in the future, they are planning to add some additional information, maybe like link utilization or delay, based on which type of anomaly or problem they'd like to detect. But that's more for the longer term, potentially. And if you need some more information about that, you should ask Christoph Graf, who is right there, and who will give a presentation this afternoon. And typically the packet capture type of tool may be for them another source of information. The next one is bandwidth on demand. So bandwidth on demand, they are planning to build sub 10 gig point-to-point Ethernet services transported over several domains. If it's several domains, that also means different technologies to carry this type of service. And that's where the monitoring of such services is becoming a challenge. And there are two main steps within the monitoring of such services. The first one is when they are setting up each piece of the service, they need to check that the path currently being built is working fine. And they need to do some out-of-service monitoring with bugs to generate some traffic through them. And the second one, the most difficult one, is when the service is in operation, how can they monitor that the service is working as they are expecting to? Because you've got several types of technologies being used in different types of domain. And Michael and Rico will be has been giving a presentation yesterday about that, about the bandwidth on demand concept. And there, potentially, the packet capture tool can also be of interest. It's not yet clear in which direction that could go, but maybe to measure bit error rate or whatever, maybe it can be somehow tweaked to measure the information that the service like bandwidth on demand could make use of. So the GRA4 is a test bed, so they don't really need any type of information, but you can make use of this test bed. So typically they will have several POPs collocated with the GN2 POPs, and they will have connectivity, so it's between towns in different locations in Europe, and the connectivity will be provided with the standard GN2 services. So typically, if at some point you need to test a tool again in a control environment, which is empty or where you inject traffic and there's nothing else, then the testbed could be useful for you to validate a tool or validate the techniques in your own dedicated environment. And if you want to make use of it, you can request it to Dante or to the GN2 project. And the last one, it's the GN2 AAI infrastructure. So they are planning to build a service which would be used by lots of other GN2 activities for the authentication and authorization. So typically, you've got a local AAA instance in your domain or within a federation or whatever, and they provide interface to communicate with this service. And they are also providing a home location service. So everybody has got his own AA infrastructure, and there is a service which allows to locate, let's say, I'm doing a request there, but I'm not part of this domain. This service will go there to find out, oh, Nicolas Simard, where is he from? Oh, it's coming from there. And there, I'll be able to be authenticated, and they will send my attributes and so on. So GRA5 is currently working on the AAI design. There's already a deliverable on the requirement, which has been written there. And it could be of interest for LOBSTER to make use of this AA infrastructure, because that would mean that if the NRENs are deploying such an infrastructure, they could also, by having LOBSTER being able to be interfaced with this AA infrastructure of GRA5, that would be a very good incentive for the NRENs to go for LOBSTER, because it's already compatible with what they have been deployed. And there is a presentation from Diego this afternoon, I guess at the same time than your presentation or Ant's presentation. So if I try to summarize quickly, there are 4 main areas which are foreseen right now for the use of passive monitoring for GN2. The first one is short time scale available bandwidth monitoring, which would be non-intrusive. The problem to monitor the whole network, we will need to deploy lots of those boxes, which is possibly not within our budget right now. The second one is the packet loss for selected flows. That's more for troubleshooting. We have observed that packet loss was something which was asked very frequently by the different people. Potentially also some detection of security problem. That's not really the goal of GRA1, but that's maybe one of the goals of the GRA2 on a longer term. And there's also the detection of anomalies and events in the network. So those are the 4 areas which are foreseen as being worked on by the GN2 project right now. So that's end my presentation. And if we wanted to have a discussion about where the boundaries between the GN2 GRA1 infrastructure and the LOBSTER one, this slide could be used as a support. So this is typically a measurement point service from GRA1, which is kind of a wrapper on top of a measurement point. And then the question would be, which part would be where, on the LOBSTER part or on the GRA1 part? But I leave it there right now.
Yes, thanks, Nicholas. So, sorry for pressing you a little bit. Are there questions, or you are hurrying away for lunch? If not, in that case, I would like to thank again for all speakers and for you, so that you came. And after the lunch, there will be another session in this room, which also is organized by LOBSTER project, and it will look into technical challenges of network monitoring. So you are very welcome to come back after the lunch.